Looking at doing the chapter test from the Calculus, a first course textbook. This is on page 156. I just had written out here that in our school we don't complete the whole chapter. We cover most of it, 3.1, 0.2, 0.3, and 0.5, but we don't do 3.4 or 3.6. So with this practice test, I'm focusing on the questions from what we have covered. So this first question I'm looking at is talking about a position of a particle, and it's given a formula, and t we know is going to have to be greater than 0 since it's time, and we're seeing where that particle is. So the first part is asking us to calculate the velocity at 4 seconds. So we want to remember that velocity is the first derivative of a position time graph, and that is our position time function, and that is what we have. So I'm going to take that first derivative, 3t squared minus 12t plus 9. Then when I want to know the velocity at 4 seconds, I will plug in 4 for all the t values, and I'll see that my velocity is 9 meters per second. In part B, it's asking us to find the acceleration at 4 seconds. So again, remembering that acceleration is the second derivative of a position time function. So we'll take that second derivative and we'll have 6t minus 12. Doing that, we now again want to know at 4 seconds. We can plug in 4 for t, and your acceleration will equal 12 meters per second squared. Part C is asking when the particle is at rest. So that it would be when our velocity equals 0. So I would look at my velocity formula, which is 3t squared minus 12t plus 9. And here I would want to factor. So my velocity formula will take out a 3, and we'll get t squared minus 4 plus, 4t plus 3. And then we will factor a little bit further here, and we'll get t minus 1 and t minus 3. Now, once we have that, then we know that we can set each factor equal to 0, and at the time t equals 1 and 3, it's when the particle would be at rest, because that's when our velocity would be 0. Moving on, I'm just going to go to the next slide here just for some more space. Moving on for when the particle is moving in the positive direction. So with this one, I like to set up a chart. So if we're looking at when it's moving in the positive direction, the times that we're looking at are when we're less than 1, when we're between 1 and 3, and when we're greater than 3, right? Because at 1, we're at 0. And we also know that our time is starting at 0, so we would not go smaller than 0. So then when we're looking at that, we could also look at the, because if it's talking about the positive direction, we are looking at when our velocity is positive, since the velocity is a scalar factor. So when it is positive, it's in the positive direction. So we are looking at our 3 factors. So we have the value of 3, we have t minus 3, and we have t minus 1, and we want to take that into consideration with our velocity. So we know that at the value 1, it's always 0. We know at the value 3, it's 0. Now we want to look at the numbers in between. So 3 is a positive number, so that's always positive. If I look at the factor t minus 3, if I plug in a number less than 1, we are going to get a negative value out. If I plug in a number between 1 and 3 for t, we also will get a negative number out. If I plug in a number bigger than 3, we will get a positive value. Looking at the next value factor of t minus 1, same idea. If we plug in something less than 1, it's going to be negative. If it's between 1 and 3, it's positive, and if it's bigger than 3, it's positive. So now we can think of multiplying. So positive, negative, and negative, that will end up being positive. In between 1 and 3, we have positive, negative, positive, that will be negative. And the last 3 all positive means we're positive. So now just to interpret that, our velocity is moving, or sorry, not just moving, but is positive between 0 and 1, and when you're greater than 3. So in terms of your time, we want to be between 0 and 1, and then we are also greater than 3. We would be in the positive direction. With E, finding the velocity when the acceleration equals 0, this time now we're looking at the acceleration formula, and your acceleration formula, we also, well, if we just go back to the first one, we have 6t minus 12. You would still want to factor this. So take out a 6 and you have t minus 2. So your acceleration is 0 when your time is 2. So that's the first bit of information, but now we want to find the velocity at that time. So now we're using that first formula for velocity. So velocity equals, and we know that was, we know that was going to be 3t squared minus 12t plus 9. So now we'll plug in 2 for the t values, and then we'll find out that your velocity will equal -3 meters per second at that time. Now the last one is talking about the total distance traveled in the first 4 seconds. So with this, I just did like a very, very simple graph with values we've kind of calculated along the way. So we know at time 0, and this is just our distance time graph, that if our starting value was 0, we are starting at the point 1. Then it's asked, our next significant time is at 1 second. That's when our particles stop moving. So at 1 second, the distance was 5. So you can just plug that into your original formula. So this part here is 5. So we know we went from 1 to 5. So that would be a total of 4 meters. Then the next time it stops is at 3 seconds. So if I plugged in 3, I would see that my next position is at 1. So to go from 5 to 1, you again traveled 4 meters. Then it's asking for the first 4 seconds. So the last one I want to check is 4. And at 4 seconds, your position goes back to 5. So that is another 4. So our total distance traveled was 12 meters. So that was our first question. If you're following along in that textbook, question number 2 is from 3.4. So we are just going to skip that over and go to question number 3. And question number 3 is a rates question. So this one is talking about the shape of a cone having height of 8 and a radius of 3. The water is poured into a cup at a rate of 2 centimeters cubed per second. And then the question is, how fast is the water level rising? So that is another rate when the water level is 6 centimeters deep. So if we start with just some information here, we have I'm going to start with the volume formula. The volume formula is 1 over 3 pi r squared times height. What I want to also recognize here, because I have 3 variables, it would be helpful to write one variable in terms of the other. And we can do that by relating a ratio of radius over height, and that is 3 over 8. So if we look at similar triangles, as that water changes or that water level changes, the radius and height are going to change, but at a related ratio. So if I isolated r by multiplying the h to the other side, I now have r in terms of h, and I can replace that value in. So I would have, just to begin with, that my volume is going to be 1 over 3, so just from the formula, pi times 3h over 8 squared times h. Now this would simplify to the volume equals 3 pi over 64 times h cubed. So I've done all of that work, and then now I can take a look at the first derivative. So if I take the derivative of the velocity and compare it to time, this part here is just a number, so I'll take the 3 out front. That's going to be multiplied by the 3 pi over 64, and then this is times h squared times the derivative of the height in terms of time. So again, we've done all of that work, but we're not quite done, because the other part that we can do is recognize that we do have the dA, or not the dH, which one do we have? We have the dV over dt. So this volume per second equals 2. So we can replace 2 here, and that will still equal 3 times 3 pi divided by 64. And then our height, we want it at 6 centimeters. So we can plug in 6 squared, and that is still multiplied by dh over dt. And that is what we're solving for. So then your last step is to isolate your dh over dt by essentially moving all of this to the other side by dividing. And then your dh over dt will equal 0.13. And then your height is in meters, time is in seconds, so meters per second. And I believe too, because, it's rising, so it would be a positive value. So those are the questions we've done. I also skipped question 4 because that is from section 3.6 using Newton's law. And I will continue tomorrow with some more videos. I'll focus on one more from rate of change as I was asked to do that. And then if you do want any other video, please leave me a comment. And as always, thank you for watching.